There's something utterly hypnotic about staring into the depths of space, a silent, endless ocean of darkness, pierced by countless pinpricks of light, each one hiding secrets we've barely begun to unravel. And among those distant islands of stars, some are far stranger than others. Take NGC 262, for example. This isn't just another galaxy floating quietly in the cosmic void. It's a treasure chest of cosmic oddities packed with objects so bizarre, they defy everything we thought we knew about the universe. Imagine glowing anomalies that flicker like ghostly beacons, structures so massive they warp the fabric of space itself, and phenomena that leave even the sharpest scientific minds scratching their heads. This galaxy, nestled millions of light-years away, isn't just a collection of stars. It's a stage for some of the most mind-bending performances in the cosmos. And today, we're going on a journey to uncover 30 of its most peculiar inhabitants. From celestial bodies that shouldn't exist to eerie formations that seem almost unnatural, each one tells a story that challenges our understanding of space. What if some of these objects aren't just random cosmic accidents? What if they're clues to something far bigger, something we're only beginning to glimpse? So buckle up, because by the time we're done, you won't just see NGC 262 as another speck in the sky. You'll see it as a cosmic puzzle, one that might just rewrite the rules of the universe as we know them. Whether you're a seasoned space enthusiast or just someone who loves a good mystery, this is one journey you won't want to miss. The deeper we go, the stranger it gets, and trust me, things are about to get very, very strange. The very first object on our list is a cosmic contortionist, a nebula unlike any other, twisting through space like a celestial serpent. Known simply as the Twisting Nebula, this bizarre structure spirals through NGC 262 with an elegance that shouldn't be possible. Most nebulae drift in gentle, cloud-like formations, their edges soft and diffuse. But this one, it coils tightly, as if some unseen hand sculpted it into a perfect helix. And here's the strange part, it's rotating against the current. While the galaxy around it moves in one direction, the Twisting Nebula spins defiantly the other way, like a swimmer fighting a relentless tide. Then there's the light. Normal nebulae glow with predictable hues, their colors dictated by the elements within them. But this one flickers with erratic pulses, shifting between ultraviolet and deep crimson in ways that leave astrophysicists baffled. Some speculate it's absorbing energy from an unseen source, perhaps a hidden black hole or a collapsed star we've yet to detect. Others wonder if something inside it is actively altering its emissions, like a cosmic dimmer switch being toyed with. What makes it even stranger is its structure. Most nebulae are chaotic, shaped by stellar winds and explosions, but the Twisting Nebula's spiral is unnervingly precise, its arms maintaining near-perfect symmetry across light years. It's as if the laws of physics took a break here, allowing this anomaly to dance to its own rhythm. Could it be the remnant of a cataclysmic event we've never witnessed? Or is it something else entirely, an object that shouldn't exist, yet stubbornly does? One thing's certain, the deeper we look, the more questions it raises. And this is just the beginning. If the Twisting Nebula left you questioning reality, wait until you meet the second enigma, NGC 262's infamous Black Hexagon. Picture this, a vast, six-sided void carved into the galaxy's dust clouds, so geometrically precise it looks as if it was drawn with a cosmic ruler. Stretching nearly half a light-year across, this pitch-black emptiness defies every expectation of how natural structures behave in space. Dust clouds typically billow and churn in chaotic, organic shapes like ink dropped in water. But the Black Hexagon, its razor-straight edges and flawless symmetry make it an unsettling outlier, as if someone or something took a scalpel to the fabric of the universe. Theories about its origin range from the mind-bending to the downright unsettling. Some researchers suggest it could be a shadow cast by an unseen megastructure, a theoretical alien construction so vast it blocks starlight in perfect geometric patterns. Imagine a civilization advanced enough to build on scales we can't fathom, leaving behind artifacts that dwarf planets. Others argue for natural explanations like freakish plasma dynamics. Under extreme magnetic fields, superheated gases can theoretically form temporary geometric shapes, though nothing observed elsewhere in the universe matches the hexagon's size or stability. Then there's the most haunting possibility. What if it's a wound, a scar left behind by some cataclysmic event, a collision with an invisible dimension, or a tear in space-time itself? What's equally baffling is what's not there. The hexagon emits no light, no heat, no radio waves, just total silence. It's not a black hole, there's no gravitational distortion. It's not a dust cloud, telescopes see straight through it. It's just absence, a perfect void where the universe seems to have forgotten to exist. Could this be a clue to deeper cosmic mysteries like dark matter's invisible architecture? Or is it proof that, even after centuries of study, space still holds pockets of sheer impossible? One thing's certain, the Black Hexagon doesn't just challenge theories, it throws them out the airlock, and we're only on Object 2. Just when you thought NGC 262 couldn't get any weirder, we stumble upon a cosmic paradox, the twin pulsars, locked in a dizzying dance that physics says shouldn't be possible. These two neutron stars whirl around each other at breakneck speeds, but here's the kicker, they're spinning in opposite directions. It's like watching a pair of figure skaters perform a perfect duet, except one is pirouetting clockwise while the other spirals counterclockwise, defying every known rule of celestial mechanics. Normally, binary pulsars form from the same stellar collapse, inheriting matching rotation patterns. But these two, they're rebels, spinning backward to each other with such precision. It's as if the universe itself got confused. The chaos doesn't stop there. Their conflicting magnetic fields slam together like invisible tidal waves, warping space-time in ways that make Einstein's equations sweat. Picture this, every time these pulsars swing close, their magnetospheres collide, generating gravity waves so intense they ripple across the galaxy. Telescopes have caught these distortions, brief flickers in the fabric of reality that vanish as quickly as they appear. Some scientists think these pulses might be whispers from higher dimensions, echoes of physics we haven't even discovered yet. Others argue the pulsars could be relics of a catastrophic encounter, perhaps one that flung them into this impossible arrangement long ago, but the real mystery. They shouldn't have survived this long. Neutron stars spinning in opposite directions should tear each other apart within millennia, their magnetic fields grinding them down like cosmic sandpaper. Yet here they are, buzzing along like perpetual motion machines. It's enough to make you wonder, are we seeing a glitch in the universe's code, or is there some hidden force, some unseen hand keeping this chaotic waltz in perfect, impossible balance? One thing's clear, in a galaxy already packed with oddities, the twin pulsars stand out as a defiant reminder that space still has plenty of tricks up its sleeve. And we're just getting started. Now, lurking in the shadow of these spinning enigmas is another head-scratcher, a phenomenon so bizarre it makes the twin pulsars look almost ordinary. But that's a story for next time. There's something chilling about an object that refuses to play by the universe's rules, and the floating monolith in NGC 262 is the ultimate cosmic rule breaker. Picture a slab of darkness roughly the size of a small moon drifting silently through the void. Its edges are so unnervingly straight, so perfectly rectangular, that at first glance you'd swear it was cut by tools rather than shaped by chaotic natural forces. Most asteroids are craggy, pockmarked remnants of violent collisions, but not this one. Its surface is smoother than polished obsidian, reflecting starlight with an almost metallic sheen, as if it's not rock at all. What's even stranger is how it moves, or rather, how it doesn't. Despite having no visible gravitational anchor, no nearby planet or star to tether it, the monolith maintains a perfectly stable orientation. It doesn't tumble or spin like every other free-floating object in space. Instead, it glides forward like a ship on autopilot, one face always locked toward the galaxy's core, as if guided by some unseen hand. Scientists have scanned it for magnetic fields, for hidden propulsion, even for exotic matter, and found nothing. It just is, defying the chaos of space with eerie precision. Then there's the light. When certain wavelengths hit the monolith's surface, they don't scatter or absorb the way they should. Instead, they bounce back in concentrated beams, almost like signals. Some researchers have joked half-seriously that it could be some kind of cosmic mirror or worse, a beacon. But for who or what, others argue it might be a natural oddity, a freak of mineral formation under conditions we've never seen. Yet even that theory falls short. Nothing in our catalogue of cosmic phenomena explains how a structure this precise, this unnatural, could exist without some form of intelligence behind it. The monolith doesn't just challenge our understanding of space, it whispers a terrifying question: what if we're not the first to shape the cosmos? What if, long before humans even looked up at the stars, something else was already out there leaving markers? Amid the cosmic menagerie of NGC 262, few sights are as unnervingly beautiful as the Crimson Vortex, a churning maelstrom of ionized gas, glowing like a freshly spilled wound against the velvet blackness of space. Stretching nearly 3 times the width of our solar system, this swirling tempest doesn't just look alive, it sounds alive too. Radio telescopes have picked up eerie, pulsing frequencies emanating from its core, rhythmic, almost melodic, like a heartbeat translated into sound. But here's the catch: those frequencies don't match the signature of any known element in the periodic table. It's as if the vortex is humming a tune written in a language we haven't yet deciphered, using notes science hasn't named. From a distance, the structure takes on an even more unsettling quality. When viewed edge-on, the vortex's concentric rings of crimson gas resolve into a shape that's impossible to ignore, a colossal, lidless eye. The central void, dark and fathomless, stares out from the galaxy like a sentinel, framed by tendrils of glowing plasma that mimic the intricate veins of an iris. It's a resemblance so striking, early astronomers studying the phenomenon nicknamed it the Watcher. Some cultures, upon seeing early renderings, even wove it into their myths as the gaze of a forgotten cosmic deity. What fuels this eerie spectacle? Theories abound. One camp argues it's the aftermath of a hypernova, a star so massive, its death throes warped the very laws of physics, leaving behind a storm of exotic matter. Others suggest it could be a natural particle accelerator, spinning charged debris at near light speeds and generating energies we've only recreated in labs. But the most spine-tingling hypothesis, the vortex might be a cosmic loophole. Some models propose that its radio pulses align with theoretical predictions for quantum tunneling, a phenomenon where particles cheat their way through barriers they shouldn't penetrate. If true, this swirling eye might not just be watching. It might be a window, however faint, into somewhere or something else entirely. Yet for all its mystery, one thing's certain: the Crimson Vortex doesn't just defy explanation. It dares us to try. With every pulse of its uncanny radio song, it whispers a challenge to science. Look closer, listen harder, because somewhere in that swirling red abyss, there's a secret waiting, one that could rewrite what we know about the fabric of reality itself. And this is just the 6th stop on our journey. Deep in the swirling arms of NGC 262, hidden among the chaos of stars and dust, lies something so unnervingly precise it feels like a cosmic prank: the trifecta of dark spheres. These 3 voids, each a perfect sphere roughly the diameter of Neptune's orbit, don't just absorb light, they devour it. Every wavelength, from radio waves to gamma rays, vanishes into their in-Chi surfaces without a trace. No glow, no heat signature, not even the faintest whisper of Hawking radiation. They're not black holes, they're nothingness incarnate, but here's where it gets eerie. These spheres aren't scattered randomly, they form a flawless equilateral triangle, their distances locked in perfect symmetry across light years of space. Even as the galaxy rotates, dragging stars and gas clouds into spiraling chaos, the trifecta holds its shape like a fixed constellation. It's as if some unseen force keeps adjusting their positions, compensating for the galaxy's motion with impossible precision. Natural phenomena don't behave this way. Gravity pulls things apart over time, orbits decay. Yet these spheres, they're locked in a geometric dance that defies entropy itself. Theories spiral from the scientific to the surreal. Some astrophysicists suggest they could be dark matter thunderstorms, regions where exotic particles have clumped into ultra-dense knots, warping space so severely that even light can't slip free. Others propose they're the aftermath of a collision between our universe and a parallel one bubble-like scars where realities briefly touched and then recoiled, leaving behind pockets of elsewhere. But the most unsettling idea, they might be markers, ancient, intentional, and placed. Consider the math. The likelihood of three identical voids self-organizing into a perfect triangle, then maintaining that alignment against the galaxy's relentless pull, is statistically negligible. It's like finding three pearls on a stormy ocean floor arranged in a straight line. Once might be chance, twice a fluke, but three, that's a pattern screaming for attention. Could this be the universe's version of a signpost, left by a civilization so advanced they've mastered the geometry of spacetime itself? Or perhaps a warning, cordoning off something we're not meant to disturb? One thing's certain, the trifecta doesn't just challenge our understanding of cosmic mechanics, it mocks it. While the rest of NGC 262 obeys the laws of physics, these spheres hover in their silent triangle, playing by rules we haven't discovered yet. And as we stare into their lightless depths, it's hard not to wonder, if this is the universe's way of leaving breadcrumbs, what or who are they meant for? But NGC 262 isn't done surprising us, because just beyond the trifecta's cold symmetry, something even stranger is waiting, cutting through the swirling chaos of NGC 262 like a cosmic tightrope. The celestial filament is a line drawn in defiance of physics. 12 light-years of pure, unbroken perfection, a thread so straight, so unnervingly rigid, it looks like the universe forgot to add curves. Most cosmic structures bend and warp under the relentless pull of gravity. Nebulae ripple like disturbed water, star clusters spiral into messy clumps, but not this. The filament remains arrow-straight, slicing through the galaxy's turbulence with the precision of a laser beam. What's it made of? That's the first mystery. Spectroscopic analysis reveals a material denser than neutron star crust, yet bizarrely flexible. Imagine a strand of spider silk woven from the fabric of a black hole, strong enough to resist shearing forces that would shred planets, yet thin enough to vanish from view if it weren't for the way it bends light around it. Some researchers suggest it could be a cosmic string, a theoretical relic from the Big Bang when spacetime itself cracked under extreme pressures. Others propose it's a scaffold of dark matter, an invisible skeleton finally revealing itself through gravitational lensing. Then there's the question of stability. Every object in the galaxy tugs at the filament, nearby stars, rogue black holes, even the galaxy's own rotation. Yet it doesn't wobble, doesn't flex. It's as if the filament exists outside the usual tug-of-war of gravity, anchored to something or somewhere we can't see. Some models hint at exotic physics, tiny, vibrating dimensions predicted by string theory, where the filament acts as a bridge between folded layers of reality. If true, it might not just be a structure, it could be a connection, but the most haunting detail, it's not alone. Scattered across NGC 262, faint echoes of similar filaments appear in telescope data, all aligned at the same exact angle. Like stitches holding the galaxy together, or perhaps like boundaries, marking territories we're not meant to cross. One thing's certain: the celestial filament doesn't just challenge our understanding of space, it hints at a hidden architecture to the cosmos, one where straight lines aren't just rare. They're impossible, and yet there it is, taunting us, waiting, because in a universe that thrives on chaos, perfection isn't just unusual, it's a message. The only question is, who's sending it? Tucked away in a quiet corner of NGC 262, the quantum crystal cluster glimmers like a cosmic chandelier, except this isn't just a dazzling light show. These geometric formations, each facet sharper than a diamond's edge, do something far more unsettling. They change when you look at them. Point a telescope toward them, and their atomic structure shifts, altering their observed properties in real time. It's as if the crystals know they're being watched, bending reality to their will like a magician's sleight of hand. But the real magic happens when you look away. Measurements taken microseconds apart show contradictory states: solid and liquid, hot and cold, existing simultaneously until observation forces them to choose. Then there's the entanglement. These crystals don't just defy local physics, they mock it. When one crystal emits a particle, its twin appears instantly in another part of the cluster. No delay, no speed of light limitation, just instantaneous connection across light years of space. Einstein called this spooky action at a distance, and here it's not just spooky, it's relentless. Particles split from the same crystal remain linked no matter how far apart they're pulled, reacting to each other's changes faster than causality should allow. It's like tossing a coin in one galaxy and watching it land heads up in another at the exact same moment. What's fueling this quantum ballet? Some theories point to extreme gravitational torsion, spacetime twisted so tightly by the galaxy's core that it creates pockets where the usual rules don't apply. Others suggest the crystals might be remnants of a primordial universe, forged when the laws of physics were still fluid, preserving a younger, wilder version of reality. But the most radical idea: these aren't natural formations at all. Their precision, their purposeful manipulation of quantum states hints at something beyond chance. Could they be tools, ancient quantum computers, or worse, experiments left behind by a civilization that mastered the fabric of reality itself? One thing's certain: the quantum crystal cluster doesn't just break the rules. It rewrites them, and every flicker of its entangled particles whispers a tantalizing question. What if the universe isn't just stranger than we imagine, but stranger than we can imagine? Because in NGC 262, even the laws of physics seem negotiable, and we're not even halfway through the list. Lurking nearby, just beyond the crystal's eerie glow, waits an anomaly so volatile it makes quantum defiance look tame, but that's a revelation for another moment. Einstein's theory of relativity painted a clear picture of how gravity bends light. Massive objects like stars or galaxies warp spacetime, creating predictable curves that magnify or distort whatever lies behind them. But deep in NGC 262, there's a place where those rules crumble. Meet the gravity lens anomaly, a cosmic funhouse mirror where light doesn't just bend, it shatters. Here, background stars don't simply stretch into arcs or duplicate into neat Einstein rings. Instead, they fracture into jagged, overlapping shards, as if someone took a hammer to reality itself. Some images appear upside down, others flicker in and out of existence, vanishing for years before reappearing slightly to the left, defying every model of gravitational lensing we've ever calculated. It's like watching a broken projector sputter fragments of the same film reel, each frame scrambled and out of sequence. Even stranger, the distortion isn't centered around any visible mass. There's no black hole, no galaxy cluster, just empty space twisting light like a child crumpling a sheet of paper. The implications are staggering. If general relativity holds, this region should require the mass of 1,000 suns to warp light so violently. Yet scans show nothing but a void. Some theorists suggest we're seeing the ghostly fingerprint of dark matter piled into an invisible knot, so dense it warps spacetime without emitting a single photon. Others propose something far more radical, that the anomaly might be a cosmic glitch, a place where the fabric of spacetime itself has frayed, revealing higher dimensions bleeding into our own. Imagine pressing your finger against a stretched bedsheet. The fabric dimples under the weight. Now imagine something outside the sheet, something we can't see or measure, pressing back. But the real mystery isn't just how the anomaly works, it's why it's here. Natural phenomena don't arrange themselves into such precise chaos. The overlapping images align in patterns that resemble geometric code, repeating sequences no random distortion could produce. Could this be nature's version of a cryptographic puzzle? Or is it something else, a signpost, a warning, or worse, a locked door we're not meant to open? Einstein once said, "The most incomprehensible thing about the universe is that it's comprehensible." Standing before the gravity lens anomaly, you have to wonder if even he'd second-guess those words. Because in this corner of NGC 262, the universe isn't just bending the rules, it's tearing them up, and the next anomaly, it doesn't just defy physics, it consumes it. Some cosmic dances aren't just beautiful, they're impossible. Meet objects 13 and 14, a pair of supermassive black holes spinning through NGC 262, separated by over 40 light-years, yet flaring in perfect unison. It's as if they're connected by invisible strings, their bursts of X-rays and gamma rays firing off simultaneously down to the millisecond. Black holes this massive shouldn't even notice each other's existence across such distances, let alone sync their activity like precision metronomes. Yet here they are, defying every expectation with eerie coordination. The first clue that something's off, their light curves. When astronomers tracked their emissions over decades, the data didn't just show similarities, it showed mirror images. One black hole's outbursts weren't merely echoed by the other. They were identical, matching in intensity, duration, even spectral fingerprints. It's the cosmic equivalent of two orchestras on opposite sides of the planet playing the same symphony at the exact same tempo, without sheet music, without a conductor, without any conceivable way to communicate. So what's linking them? One radical theory suggests quantum entanglement. The same spooky connection binding particles in labs on Earth might be scaling up to monstrous proportions. If these black holes share entangled particles in their accretion disks, changes to one could instantly affect the other, transcending the speed of light. But here's the catch: entanglement at this scale would require mechanisms we've never observed, weaving space-time itself into a web of instantaneous influence. Others propose a darker twist. What if these aren't two separate black holes at all? Some models hint they could be projections of a single hyperdimensional object, a cosmic mirage created when a higher dimensional black hole intersects our three-dimensional space at 2 points. Picture poking a finger through a sheet of paper. To flatlanders living on that sheet, it would look like two separate circles. Could we be seeing the same illusion on a galactic scale? Then there's the silence. These black holes don't just flare in sync, they go quiet together too. For years at a time, both shut down simultaneously, their accretion disks dimming to near invisibility before roaring back to life in lockstep. Its behavior more reminiscent of a machine cycling power than natural celestial bodies. One astronomer famously likened it to watching two lungs breathing inside an invisible cosmic beast. Whether it's quantum threads, hidden dimensions, or something even stranger, one thing's clear. This synchronized duet isn't just rewriting the rules of astrophysics, it's composing an entirely new score. And the next object in NGC 262, it doesn't just break rules, it erases them entirely. Amid the cacophony of cosmic noise, the screech of pulsars, the hiss of solar winds, one object in NGC 262 doesn't just sound different. It sings. The Singing Comet glides through the void like a frozen maestro, its tail shimmering with icy particles that pulse in time to a melody no one expected to find in the depths of space. But this isn't random static or the usual crackle of charged particles. When radio telescopes first captured its signal, scientists didn't just hear noise, they heard music. Harmonic frequencies layered into precise mathematical sequences, their intervals mirroring the same ratios found in Earth's most ancient musical scales. It's as if someone transcribed a symphony onto the fabric of the cosmos itself. The composition evolves. Over decades of observation, the comet's emissions have shifted through distinct movements, languid, mournful drones giving way to staccato bursts, then resolving into something resembling a chorus. What's chilling is the structure. The sequences repeat in patterns too complex to be random, cycling through prime-numbered intervals and Fibonacci progressions. One astronomer compared it to listening to a cosmic pianist improvising variations on a theme, each note mathematically flawless. Even stranger, the song occasionally responds to external stimuli. When probes blasted it with targeted radio pulses, the comet's frequencies shifted within minutes, altering its tune as if in conversation. Natural explanations strain under the weight of these details. Comets typically emit chaotic radio noise as solar radiation ionizes their surfaces. But this level of coherence, this intentionality, some researchers argue it could be plasma vibrations resonating through the comet's unique crystalline ice, a natural radio transmitter sculpted by bizarre chemistry. Others point to piezoelectric effects, where stress fractures in the ice generate electrical signals that oscillate into harmony. But then there's the Pythagorean twist. The intervals between frequencies align exactly with the same mathematical constants humans used to build our first musical instruments. Coincidence? Or something more, the most spine-tingling theory, the singing comet might not be singing for itself. Scans reveal its icy core is laced with microscopic tunnels perfectly hexagonal, as if etched by precision tools. Some whisper these could be remnants of an ancient antenna array designed to broadcast its melody across the galaxy. To what end? A beacon, a message? Or perhaps a fingerprint left by a civilization that turned comets into artworks or instruments. Whatever the truth, one thing's clear: this isn't just a comet. It's a performance, and as its song echoes through the void, it begs a question that lingers long after the last note fades. In a universe teeming with noise, who or what composed this? Because the next object in NGC 262 doesn't just whisper secrets, it screams them. If the singing comet felt like a serenade from the cosmos, the plasma sculpture is the universe's attempt at modern art. Except this masterpiece doesn't just hang on a wall. It lives, suspended in the heart of NGC 262. This swirling mass of ionized gas shouldn't be anything special. Plasma clouds typically twist and fade, their forms as fleeting as smoke in the wind. But this one, it holds shapes, not just random blobs, recognizable, intricate silhouettes that linger for days, even weeks, before dissolving into new configurations. And one shape, in particular, sent chills down the spines of every astronomer who witnessed it, a humanoid figure, clear as a shadow cast against the inferno. The first sighting came from the Hubble's deep field scans, a brief flicker in the data that seemed too bizarre to be real. But then other telescopes caught it too, the same towering outline, arms slightly outstretched, standing motionless in the plasma storm. For exactly 47 minutes, it held its form, down to the faint suggestion of a face. Then, like a sand sculpture meeting the tide, it melted back into the chaos. Skeptics called it pareidolia, the brain's habit of seeing faces in random patterns, but the math disagreed. The probability of plasma self-organizing into such a precise shape multiple times was less than winning the lottery while struck by lightning. Twice, what's fueling this impossible artistry? Some theories point to magnetic, locking https://n. Wikipedia, org/wiki/magnetic reconnection, a phenomenon where supercharged particles get trapped in standing waves like ink suspended in swirling water. Others suggest the sculpture might be a cosmic hologram, its shapes projected by gravitational lensing from some unseen structure behind it. But the most unsettling idea. It's not just forming shapes, it's mimicking them. Scattered through decades of observations are eerie recurrences. A bird with outstretched wings, a twisting double helix, even a near-perfect replica of the pyramids of Giza. As if the sculpture isn't just playing with physics, it's playing with us. Then there's the temperature. Normal plasma sculptures would vaporize anything that got close, radiating heat measurable in millions of degrees. But this one, its surface roils at a relatively cool 2000 degrees, almost as if it's holding itself back. One astronomer described it as a wildfire that's learned to paint. Whether it's a natural freak or something far stranger, the plasma sculpture doesn't just defy expectations. It holds up a mirror to them, whispering a question we've barely begun to ask. In a universe where matter can remember its shapes, what else might be possible? And as we turn away from this living artwork, NGC 262 has already prepared its next Act 1, where the laws of time itself start to unravel. Among the swirling anomalies of NGC 262, few sights are as hypnotically impossible as the impossible rings. 3 concentric bands of dust and debris, each spinning at dramatically different speeds, yet locked in an eternal dance where they never touch. It's like watching a cosmic ballet where every dancer moves to their own rhythm, yet somehow avoids colliding with the others. The outermost ring drifts lazily, completing one full rotation every few centuries. The middle ring whips around like a frenetic carousel, spinning hundreds of times faster, and the innermost ring, it spins backward, defying every expectation of how celestial objects should behave. These aren't just any dust rings, they're a middle finger to physics. Angular momentum, the law that keeps everything from spinning stars to figure skaters in balance, demands that objects rotating in the same system should influence each other. Friction alone should drag these rings into chaos, merging them into a single, messy disk. But here, the laws seem to have taken a vacation. The rings pass through each other's orbits like ghosts, their particles never colliding, never scattering. Even Saturn's iconic rings, with their intricate divisions, can't compare to this defiance. Saturn's gaps are carved out by shepherd moons' tiny gravitational sculptors, nudging debris into place. But scans of the impossible rings show nothing holding them apart. No hidden moons, no magnetic fields, just perfect, unbroken symmetry where there should be pandemonium. So what's really going on? One theory points to quantum locking, a phenomenon where charged particles under extreme conditions can freeze into non-interacting lanes like cars on an invisible highway. Others propose that the rings aren't made of ordinary matter at all, but of dark matter filaments woven so tightly they've taken on the illusion of solidity. But the most mind-bending idea, time might be flowing at different rates inside each ring. If the innermost ring exists in a slightly warped space-time bubble, its backward spin could be an illusion, a trick of relativity where backward is just our perspective from the outside. Yet for all the theories, one haunting detail lingers. The rings aren't static. Every few decades, their speeds shift in perfect unison, as if some unseen hand is fine-tuning their dance. It's a precision that whispers of design, of something, or someone orchestrating the impossible. And as we stare at these spinning enigmas, we're left with a chilling thought. If the universe can bend its own rules this effortlessly, what else is it hiding? But NGC 262 isn't done with its revelations, because nestled just beyond these rings lies something even stranger, a place where light doesn't just bend, but splinters into fragments of forgotten colors. There's a corner of NGC 262 where time itself loses its grip, a billowing nebula known as the time-dilation cloud, where clocks don't just tick. They stutter. Probes sent into its depths return with data logs in chaos. Onboard computers reporting missions lasting days, while external observers swear only hours passed. One expedition's instruments recorded a single minute stretching into 17, as if the cloud had paused the universe's metronome mid-beat, but the real terror. There's no pattern, no gradual shift, no predictable warp. Time here doesn't flow like a river, it shudders like a stuck film reel, speeding up and slowing down at random. What creates this temporal turbulence? Gravity alone can't explain it. While black holes stretch seconds into eons, their effects are at least consistent, get close enough, and relativity's equations hold firm. But the time dilation cloud mocks those rules. Its distortions flicker unpredictably, like a light switch controlled by a capricious god. Some theorists suggest it's a knot of quantum foam, a seething froth of space-time at the smallest scales, where tiny wormholes blink in and out of existence, each one bending time in its own way. Others propose the cloud might be saturated with exotic matter, particles that should exist only in the earliest moments of the Big Bang, bubbling up like ghosts to toy with causality. Then there's the silence. Every probe that's ventured deeper than the cloud's outer layers has stopped transmitting, not malfunctioned, not gone dark. Just frozen, their final signals arrive years later, stretched into whispers, as if the messages are fighting their way through honey-thick time. The last transmission from probe 732 was particularly chilling. A single frame of video showing the craft's instruments intact, its power readings nominal, but its timestamp jumping erratically between the years 2047 and 12,831. As if the cloud wasn't just warping time but shredding it. Could this be a window into higher dimensions? Some models suggest the cloud might sit at the intersection of multiple timelines, a cosmic crossroads where alternate realities bleed together. Others argue it's evidence of a universe still cooling from its birth, with patches of spacetime yet to set into their final, stable form, but the most unsettling possibility. We're not seeing a natural phenomenon at all. The cloud's edges are too precise, its distortions too neatly contained, like an experiment left running or a lock waiting for the right key. One thing's certain, in a galaxy already brimming with cosmic rule breakers, the time dilation cloud stands apart. Because while other anomalies twist space or defy gravity, this one does something far more intimate. It reaches into the one constant we thought we could rely on, the steady march of time, and proves even that isn't safe from NGC 262's chaos. And just beyond its shimmering veil, the next object waits, a structure so vast it doesn't just occupy space, it defines it. Buried in the swirling outskirts of NGC 262, the Mirror asteroid hangs in the void like a cosmic antique shop window, except instead of dusty trinkets, its surface reflects scenes from Earth's past. This tumbling rock, roughly the size of Mount Everest, doesn't just scatter light like ordinary asteroids. It replays it. Gaze at its polished facets, and you'll see glimpses of our own planet, but not as it is today. The images shimmering back are a century old. Smokestacks belching over 1920s skylines, biplanes buzzing above untouched forests, silent film stars frozen mid-gesture. It's as if someone carved a time span into the asteroid's very atoms, programming it to echo a specific era of light across the cosmos. How does it trap these ancient photons? The leading theory involves an insane fluke of physics. The asteroid's crust is laced with a crystalline mineral that acts like a slow-motion mirror. Normally, light bounces off surfaces at, well, light speed, but this material's atomic structure delays photons, forcing them to ricochet through a labyrinth of molecular pathways before finally escaping, a detour that, for some reason, takes exactly 100 Earth years. It's as if the asteroid's surface is a hall of mirrors where light gets lost in corridors of time before finding its way out. But here's where it gets eerie. The reflections aren't fuzzy or fragmented, they're curated. The asteroid doesn't show random slices of the past. It focuses on human activity, crowded city squares, roaring locomotives, even intimate moments like children playing on long-vanished beaches. As if it's not just reflecting light but selecting it, some astronomers suggest gravitational lensing from NGC 262's core might be bending historical Earth-light toward the asteroid in precise patterns. Others note something stranger. The images update annually, cycling through the years like pages in a scrapbook. Then there's the fracture. In 2019, a chunk of the mirror asteroid broke off, and the new face revealed beneath didn't show the past. It showed possible futures, grainy, shifting visions of Earth's next century. Cities submerged under rising tides, forests regrowing over crumbling highways, even what looks like massive orbital structures hovering over the planet. Are these prophecies or just cosmic static? The asteroid isn't telling. But one detail chills researchers to the core. The future fragments align unsettlingly well with humanity's most accurate climate models. So is it a natural oddity or something more? The asteroid's composition defies categorization. Its crystal lattice resembles nothing in our solar system. Some whisper it could be a message in a bottle, hurled into the cosmos by an intelligence that understands light the way we understand ink. Others argue it's a cosmic recording device, built to preserve fragments of civilizations destined to flicker out. But the truth might be simpler and far stranger. Maybe the universe likes keeping souvenirs, and if one rock can hold a century of memories, what else might be floating out there, waiting to reflect our story back at us? Because in NGC 262, even the past isn't safe from the galaxy's obsession with rewriting the rules, and the next object, it doesn't just bend time. It folds space like origami, drifting through the dust lanes of NGC 262 like a ghost from the abyss. The cosmic jellyfish is a living paradox, a creature of the void that shouldn't exist, yet glows with undeniable presence. Its body, a luminous orb of swirling plasma, pulses with rhythms eerily reminiscent of a heartbeat, while its trailing tendrils stretch light years into the darkness, each one crackling with ionized particles that flicker like underwater bioluminescence. This isn't just a nebula, it's a performance, one where physics and spectacle collide in ways that leave astronomers equal parts mesmerized and unnerved. What sets this structure apart isn't just its shape, it's the behavior of those tentacles. Normal ionized gas disperses chaotically like ink in water. But these filaments move with eerie coordination, curling and uncurling in sync with the jellyfish's central pulses. It's as if the entire structure is breathing, its tendrils contracting in slow, deliberate waves that defy the randomness of space. Even stranger, the pulses aren't random. They follow a cycle precise to the millisecond, repeating every 6 hours, 19 minutes, and 42 seconds like a celestial metronome. No known stellar remnant or black hole accretion disk matches this rhythm. It's a tempo without a conductor. Then there's the light show. When the jellyfish pulses, its tendrils ignite in cascading bursts of color, shifting from cobalt to violet to a searing gold, as if running through some unseen spectrum. Spectrographs reveal these aren't just thermal emissions. The light carries signatures of elements that should be impossible to excite at such low energies, like oxygen and nitrogen glowing as fiercely as if they were inside a star's core. It's the cosmic equivalent of a candle burning at the temperature of a supernova. Some researchers theorize the jellyfish might be tapping into zero-point energy, the quantum froth of spacetime itself, to fuel these displays. Others whisper about artifacts, ancient, engineered structures hidden in the tendrils, acting like neon signs in the abyss. But the most haunting detail: the jellyfish isn't drifting aimlessly, it's hunting. Over decades of observation, its path has traced a slow spiral toward a cluster of young, volatile stars. Every time it passes one, its tendrils stretch toward the star's magnetic field like fingers grasping for prey, and the star without fail dims, not from eclipses or dust. Its luminosity drops as if something is siphoning its energy, leaving behind a cooler, quieter version of itself. The jellyfish, meanwhile, glows brighter. Coincidence or something more? One theory suggests this might be a natural, if freakish, form of cosmic symbiosis, where the jellyfish feeds on stellar winds like its earthly counterparts filter plankton. Another, more unsettling idea posits that what we're seeing isn't natural at all, but the remnant of a technology designed to harvest stars, left adrift long after its builders vanished. Whatever the truth, the cosmic jellyfish doesn't just blur the line between organism and phenomenon. It erases it, and as it pulses lazily through the dark, one thing becomes clear. In NGC 262, even the vacuum of space isn't empty. It's alive because the next object in this galaxy doesn't just glow or move. It calculates spinning equations into reality with the precision of a supercomputer forged from stardust. Among the swirling enigmas of NGC 262, two stars stand out not for their brilliance but for their absence. Objects 23 and 24 flicker like dying embers, their light dipping in erratic, geometric patterns that make no sense for ordinary stellar bodies. These aren't variable stars or eclipsing binaries. Their dimming happens in jagged, unnatural steps, as if something vast and artificial is methodically blocking their glow piece by piece. Welcome to the Dyson Sphere candidates, where the line between cosmic phenomenon and cosmic engineering blurs beyond recognition. The first star, Candidate 23, dims in precise 90-degree increments, its light dropping in sharp, angular transitions rather than smooth curves. It's the kind of pattern you'd expect from a rotating megastructure, something with hard edges, like a colossal latticework of solar panels or a fragmented ring world. The second, Candidate 24, is even stranger. Its light doesn't just dip, it flickers in bursts that match prime-numbered sequences, a pattern so mathematically deliberate it's been compared to Morse code written in starlight. Even more unsettling, both stars emit excess infrared radiation, the telltale signature of waste heat, exactly what you'd expect if something was capturing their energy and radiating it at lower temperatures. Theories spiral from the plausible to the extraordinary. On the tame end, some astrophysicists argue these could be swarms of comet fragments or rogue planets with bizarre orbits, casting shadows in unnatural ways. But the numbers don't add up. The energy signatures are too clean, the patterns too precise. Then there's the Dyson swarm hypothesis, the idea that an advanced civilization might build vast arrays of energy collectors around their star, harvesting its power like bees tending a hive. It's a concept straight out of mid-20th century speculation, but here, in NGC 262, it's playing out in real time, but the most haunting possibility. These aren't full Dyson spheres, they're construction sites. The irregular dimming, the heat signatures, they match simulations of partially built megastructures, where sections are still being assembled or calibrated. Imagine scaffolding on a cosmic scale with sunlight peeking through the gaps. If true, we might be witnessing the birth of something unimaginable, a civilization rewriting the rules of energy itself, turning stars into batteries. Yet for all the speculation, one question lingers like a shadow. If these are artificial, where are the builders? The stars show no signs of spacecraft or transmissions, just those silent geometric eclipses ticking away like clocks in the dark. It's a reminder that in a universe this vast, even absence can be a message. And in NGC 262, the quietest stars might be screaming the loudest secrets. Because the next object doesn't just hide in darkness, it feeds on it, a cosmic predator lurking in the gaps between light and shadow. The universe doesn't do perfect, chaos is the rule, accidents the norm. Yet nestled in the aftermath of NGC 262's most violent stellar death lies an insult to that logic, the Fibonacci supernova remnant, where debris didn't just scatter. It composed itself, stretching nearly 12 light-years across. This swirling graveyard of a once massive star doesn't resemble the usual messy blast patterns. Instead, its shockwaves froze into spirals so mathematically precise, you could sketch them with a protractor. Each filament of glowing gas coils outward at exactly 23.5 degrees, branching into smaller spirals that shrink in perfect golden ratio progression, 1.618 times smaller with each turn, the same ratio found in nautilus shells and sunflower seeds. It's nature's favorite number etched into a cosmic explosion. Statistically, this shouldn't exist. Supernova are cosmic grenades. Their shockwaves rip through space at millions of miles per hour, shredding everything in their path into chaos. Even the most beautiful remnants, like the Crab Nebula, are still tangled webs of debris. But here, the Fibonacci remnant spirals hold their symmetry like a dancer mid-twirl, unbroken by turbulence or time. Astrophysicists have run countless simulations trying to recreate such order from stellar violence. The results, either shapeless clouds or lopsided fragments. Never precision whispering of a hidden blueprint. So what bent physics to its will? One theory points to the star's rotation. If it spun fast enough in its final moments, like a figure skater pulling their arms in, the centrifugal force could have sculpted the explosion into spiral arms. But calculations show the star would have needed to rotate at nearly 90% of light speed, a feat thought impossible for anything but theoretical quark stars. Another idea suggests magnetic fields thousands of times stronger than any observed might have funneled the debris into these eerie curves, like invisible hands shaping smoke. Then there's the shadow in the data. At the remnant's heart, where the neutron star or black hole should be, there's nothing. Just silence, no pulsar beams, no accretion disk glow, as if the core vanished, leaving behind only these spirals like a cosmic signature. Some speculate the star didn't just die. It unraveled, its matter decompressed into higher dimensions we can't perceive, imprinting this pattern as a farewell note in three-dimensional space. But the most haunting detail, the remnant isn't static. Every 17 years the spirals pulse, their glow brightening in sequence from the center outward, like a clockwork flower blooming in slow motion. It's a rhythm with no known energy source, no residual heat to explain it, as if the remnant isn't just debris. It's a machine counting down to something or waiting to be read. Because in NGC 262, even destruction obeys a hidden harmony, and the next object, it doesn't just defy expectations, it wears its impossibility like a crown. The laws of gravity are supposed to be universal. What goes up must come down, and massive objects pull everything toward them. But deep in NGC 262, there's a place where the universe seems to have forgotten its own rules. Welcome to the gravity well paradox, a region where objects don't fall toward the galaxy's core, they defy it. Here, rogue asteroids, drifting gas clouds, even light itself curve away from the expected pull, soaring upward like sparks from a campfire. It's as if someone flipped gravity's switch to reverse, leaving astronomers scrambling for explanations. At first glance, the paradox looks like any other patch of space, no swirling vortices, no eerie glows. But the moment something enters its influence, the madness begins. Probes sent to map the area veer off course, their trajectories bending at right angles to every predictive model. Dust clouds that should be collapsing inward instead billow outward in perfect defiance, their particles accelerating against the gravitational tide. Even light passing through the region refracts unnaturally, bending toward emptiness instead of mass. It's a cosmic game of anti-gravity, and the rules are anything but clear. So what's behind this defiance? One leading theory points to an Einsteinian nightmare, a wrinkle in spacetime so extreme it acts like a funhouse mirror for gravity. Imagine pressing your palm into a stretched rubber sheet. Normally, it creates a dip that draws objects inward. But if the sheet were somehow folded backward, your hand might create a hump instead, repelling anything that comes near. Some researchers suggest the paradox could be a negative mass region, where exotic matter warps the fabric of the cosmos in reverse. The only problem: negative mass has never been observed, only theorized. Another idea hinges on hidden dimensions. string theory suggests our universe might be floating like a bubble in a higher dimensional void. If that's true, the paradox could be a spot where those unseen dimensions leak into ours, twisting gravity's arrow until it points in the wrong direction. It's like trying to navigate a maze while someone secretly rotates the map. What seems like forward might actually be up, but the most unsettling explanation. The paradox isn't natural at all. Its boundaries are suspiciously geometric, forming a near-perfect sphere exactly 7 light-years wide. Natural phenomena don't carve themselves into such precise shapes. Could this be the aftermath of some ancient technology, a gravity engine left running on autopilot, or worse, a weapon that flips the fundamental forces like a light switch? One thing's certain, the gravity well paradox doesn't just bend the rules, it snaps them in half, and as we stare into this pocket of cosmic disobedience, we're left with a chilling thought. If gravity can't be trusted here, what else might be lurking in the gaps between the laws we think we know? Because the next object in NGC 262 doesn't just play with physics, it erases them entirely, a void where the universe's constants start to unravel. There's a trio of lights in NGC 262 that don't just shine, they communicate. Meet the trinity of light, 3 radiant spheres suspended in the void, each separated by thousands of light years, yet pulsing in perfect chromatic harmony. One flickers cobalt, and within milliseconds the others echo the exact same hue, shifting seamlessly to emerald, then crimson, then gold, as if choreographed by some unseen cosmic conductor. The staggering part, this synchronicity defies causality. Even at light speed, signals between them should take millennia to traverse the distances, yet their color changes are instantaneous, a silent conversation unfolding faster than physics allows. The first of the trio, Object 27, anchors the group with a steady, rhythmic pulse, its surface rippling like liquid metal. Observations reveal its light isn't just reflecting, it's generating wavelengths from scratch, emitting colors no nearby stars could possibly excite. Object 28, meanwhile, orbits nothing. It drifts alone in the darkness, yet its emissions mirror 27's shifts down to the nanosecond, as if tethered by invisible threads. Then there's Object 29, the wild card. Unlike its siblings, it doesn't just mimic, it anticipates. Half a dozen times in recorded history, its color has changed a fraction of a second before the others, like a dancer leading the troupe. So what's linking them? One theory suggests quantum entanglement scaled to cosmic proportions somehow. These objects share particles entangled at birth, their states forever intertwined across the void. It's a stretch, though. Entanglement typically breaks down over macroscopic distances, and nothing in known physics explains how entire celestial bodies could maintain such a bond. Another idea points to hidden dimensions. If the Trinity exists in a higher dimensional space, their apparent separation in our 3-dimensional view might be an illusion, their true forms folded together like origami. But the most electrifying possibility, they're not natural. Their color sequences aren't random. They follow intricate, repeating algorithms resembling error-correcting codes, the kind used in digital transmissions. It's as if we're not just witnessing a phenomenon, but decoding one. Could these be nodes in a galactic-scale network relaying information across the abyss? Or perhaps something more mundane, a freak of plasma dynamics, where resonant frequencies align by chance. One haunting detail lingers. Every 73 years, the Trinity's synchronicity stutters. For exactly 11 minutes, their colors scatter into chaos before snapping back into unison, as if recalibrating. Natural systems don't reset like clocks. Machines do, and as we watch these luminous sentinels pulse their cryptic signals into the dark, it's hard to shake the feeling that somewhere, someone, or something is listening. Because in NGC 262, even light doesn't just illuminate, it speaks, and the next object, it doesn't just break the rules, it rewrites them in the language of pure silence. At the edge of NGC 262, where the galaxy's light begins to fray into the abyss, the cosmic computer hums its silent song, a grid-like structure spanning nearly 5 light-years, its intersecting beams glowing like circuitry etched into the fabric of space itself. Unlike the chaotic scatter of stars around it, this latticework of luminous filaments pulses with eerie regularity, firing off bursts of energy in sequences so precise they've been compared to binary code. Each pulse lasts exactly 1.27 milliseconds, followed by intervals of darkness that correspond to mathematical constants, pi, the golden ratio, even the fine structure constant that governs the universe's fundamental forces. It's as if the cosmos itself is running an algorithm, and we've stumbled onto its display screen. Deciphering these signals has sparked both wonder and skepticism. Early attempts to translate the pulses into binary yielded fragments of what looked like coherent messages repeating prime numbers, geometric coordinates, even what some claimed were atomic weights of elements not yet discovered on Earth. One particularly controversial decode appeared to map the structure of DNA, albeit with a 12th base pair that doesn't exist in any known organism. Critics argue these messages are just pareidolia, the human brain imposing patterns on randomness, but the numbers don't lie. The odds of these sequences occurring naturally are slimmer than a snowball surviving a supernova. What powers this celestial mainframe? Theories range from the mundane to the mind-bending. Some astrophysicists suggest it could be a natural quantum resonance, where magnetized plasma aligns into conductive wires, channeling energy like a cosmic Tesla coil. Others point to the grid's uncanny resemblance to theoretical models of a matryoshka brain, a hypothetical supercomputer built around a star, harvesting its energy to perform calculations at scales we can't fathom. If true, the cosmic computer might not just be transmitting data. It could be processing reality itself, running simulations or solving equations beyond our comprehension. Then there's the silence. Every 17 hours the grid stops. For exactly 6 minutes and 9 seconds, the pulses cease entirely, as if the system is rebooting. During these pauses, deep space radio telescopes pick up faint, wide-band static, what one researcher described as the sound of a cosmic hard drive clicking off. Natural phenomena don't take coffee breaks, machines do. Whether it's a freak of physics or something far more profound, the cosmic computer challenges the very definition of natural. Because in a universe where even the vacuum thrums with quantum activity, the line between accident and design starts to blur. And as we listen to its pulsing code, one question lingers. If this is a message, are we the intended recipients or just eavesdroppers on a conversation we'll never understand? NGC 262's final enigma doesn't just whisper secrets. It forces us to confront the unsettling possibility that some mysteries aren't meant to be solved, only witnessed. And with that, our journey through this galaxy of wonders comes to a close, though its questions will echo far longer. Years of observation have only deepened the mystery of the Black Hexagon because against all odds, this cosmic anomaly hasn't changed. Not a fraction, not a flicker. While the galaxy around it churns with motion, this six-sided void remains locked in perfect geometric stasis, its razor-sharp edges unblurred by time or turbulence. Recent high-resolution scans from the James Webb Space Telescope reveal something even more unsettling. The hexagon isn't just holding its shape, it's correcting it. Minute gravitational nudges from passing stars or gas clouds should warp its structure over decades, yet the hexagon's angles self-adjust with eerie precision, snapping back to exactly 60 degrees like a cosmic pane of glass-resisting scratches. What's fueling this unnatural stability? New simulations point to an invisible scaffold, a network of gravitational anchors that might be pinning the hexagon's edges in place. Imagine 6 black holes, each smaller than a grain of sand yet impossibly dense, positioned at the vertices. Their combined pull could theoretically maintain the shape, but there's a catch. No such micro-black holes have ever been detected, and their existence would require physics beyond our current models. Then there's the light paradox. The hexagon doesn't just absorb visible light, it rejects it, photons skimming its boundary curve away as if repelled by an unseen force, creating a faint hexagonal aura of warped starlight. Some researchers now speculate the void might be lined with a shell of exotic matter particles that warp spacetime so severely they act like one-way mirrors for gravity, bending the very fabric of the universe inward to maintain its flawless edges. But the most radical theory, the hexagon isn't an object at all, it's a shadow. Data from neutrino detectors hints at an immense, translucent structure lurking just beyond our visual spectrum, a megastructure so vast, its six-sided silhouette is projected onto the dust clouds of NGC 262 like a cosmic sundial. If true, we're not staring at emptiness, we're staring at the outline of something else, something waiting to be seen. Because in a galaxy where even the laws of physics seem negotiable, the hexagon stands as a silent monument to the universe's unfinished rulebook, and every unchanging angle whispers the same terrifying question: what if stability isn't natural? What if it's engineered? The answer might lie in the one anomaly even the hexagon can't ignore, but that's a revelation for another moment. The Singing Comet doesn't just hum random notes, it composes symphonies written in the language of mathematics. Over the past decade, astronomers have isolated its radio pulses into distinct tonal sequences, each one adhering to patterns so precise. They've sparked debates about whether we're hearing nature's randomness or something more deliberate. The latest analysis reveals a staggering depth to these patterns, nested harmonic progressions that mirror the Fibonacci sequence, chord progressions aligning with the golden ratio, even rhythmic intervals matching prime-numbered frequencies. It's as if the comet's song is an equation-given sound, a musical representation of the universe's hidden scaffolding. What's truly unsettling is how these sequences evolve. Early recordings from the 1970s show simple, repeating loops, a three-note motif cycling every 12 minutes. But recent observations capture layers of complexity stacking like fractals. The comet now weaves counter-melodies, sudden key shifts, and syncopated rhythms that resemble the structure of human compositions, from Bach's fugues to the pentatonic scales of ancient folk music. Some researchers argue this progression mirrors the development of human music theory, as if the comet is learning or worse, teaching. Then there's the encryption theory. When converted into binary code, certain tonal sequences translate into geometric shapes, circles, triangles, even three-dimensional wireframes of molecular structures. One particularly infamous decode matched the isotopic ratios of a hypothetical element predicted by quantum physicists, unbihexium, a super-heavy atom that could theoretically exist in neutron star crusts. Coincidence or a cosmic Rosetta Stone broadcasting formulas we haven't discovered yet? Skeptics point to natural resonances. Plasma vibrations in the comet's tail, they argue, could mimic musical intervals if subjected to the right magnetic fields. But this doesn't explain the adaptations. In 2021, a team at the Arecibo Observatory beamed a sequence of prime-numbered radio pulses toward the comet. 48 hours later, its emissions shifted to incorporate those same primes into its melody, a response time too rapid for natural plasma oscillations. It's behavior that straddles the line between reaction and recognition. Perhaps the most haunting possibility isn't that the comet is sending messages, but that it's testing us. Its song's escalating complexity mirrors the way a teacher might scaffold lessons, starting with arithmetic before introducing calculus. Are we the students in this metaphor? Or is the universe itself the classroom with the comet as its chalkboard? One thing's certain, in NGC 262, even silence sings, and the longer we listen, the louder the questions become. Because the next object doesn't just communicate, It calculates spinning equations into reality with the cold precision of a machine older than stars themselves. Time doesn't just flow differently in NGC 262, it fractures. Scattered across this galaxy, anomalies whisper a terrifying truth. The laws of causality here aren't just bent. They're optional. Consider the evidence. The time dilation cloud churns with pockets where seconds stretch into hours, while the mirror asteroid replays Earth's past like a stuck record. The quantum crystal cluster forces particles to exist in multiple states simultaneously, and the gravity lens anomaly shatters light into temporal shards, showing scenes from the future alongside the past. Even the Fibonacci supernova remnant pulses with a 17-year rhythm, as if counting down in a time signature we don't yet understand. These aren't isolated oddities. They're stitches in a tapestry, weaving together a galaxy that might exist outside the linear flow we take for granted. Imagine spacetime as a river. In our universe, it moves in one direction, carrying everything from birth to decay in an unbroken current. But in NGC 262, the river has whirlpools. Eddies where time loops back on itself, waterfalls that plunge into reverse. The cosmic computer's binary pulses might not just be calculations, they could be timekeeping, synchronizing events across eras we perceive as separate. The trinity of light's instant communication across light years hints at a reality where now isn't a universal constant but a local condition. Even the plasma sculpture's shifting forms echoing human faces and ancient structures suggest it might not just reflect history but access it, plucking images from timelines that haven't or shouldn't exist yet. The implications are staggering. If time in NGC 262 is more like a mosaic than a straight line, could entire civilizations rise and fall in the gaps between our observations? Are the Dyson sphere candidates not just megastructures but time capsules built by a species that mastered temporal engineering? The Singing Comet's evolving melodies could be a message not just from distant space but from distant eras, its song growing more complex because it's been transmitting for millennia longer than we've been listening. Even the Black Hexagon's unnatural stability makes grisly sense in this context if it's anchored not just in space but in time, a fixed point in a fluid continuum. Here's the chilling thought: we might not just be studying a galaxy, we might be studying a palimpsest, layer upon layer of reality stacked in ways we can't yet peel apart. The universe's rulebook was written in ink, but NGC 262 scrawls its own margins in something darker, a place where before and after don't mean what they should. Where the past might be listening and where the future, whatever it holds, might already be here. Lab coats and supercomputers have collided in a desperate race to unravel the quantum crystal cluster's secrets, but what happens when the universe refuses to cooperate? For decades, researchers from Geneva to Tokyo have tried to replicate Object 11's mind-bending properties in controlled settings, only to watch their experiments spiral into chaos. The first attempt, led by CERN in 2019, aimed to trap entangled particles in a diamond lattice chilled near absolute zero. The result, a $3 million lab explosion that left sensors detecting particles vanishing mid-measurement, as if the crystals had flickered out of existence the moment observation began. Then came the plasma vortex experiments, massive magnetic chambers designed to spin ionized gas into mimicries of the cluster's helical structures. For a few milliseconds, it worked. The artificial crystals pulsed with eerie synchrony until the entire system inverted. Temperatures near the vortex's core plummeted to negative 270 degrees Celsius, a state thought impossible, where atoms should cease moving entirely. Instead, they vibrated faster, emitting frequencies that shattered every sensor in the room. The lead physicist later described it as watching thermodynamics run backward while the universe laughs. Why do these replications fail so spectacularly? The answer might lie in what we're not accounting for. The quantum crystal cluster doesn't just defy physics, it exists in a gravitational sweet spot near NGC 262's core, where spacetime itself is warped by unseen forces. Earth labs can't simulate that. MIT's quantum team learned this the hard way when their nanoscale crystal analogs started time drifting, particles in the same experiment behaving as if seconds apart, like a film reel missing frames. The implications: Object 11 might not just be entangled in space, but in time, its particles existing in multiple moments simultaneously. The most haunting failure came from a privately funded lab in Singapore. Using AI to simulate the cluster's Fibonacci patterned emissions, they accidentally created a feedback loop where the system began self-correcting, altering its own code to match readings from the actual cluster light years away. As if the replica wasn't just a copy but an extension of the original, the experiment was shut down when technicians reported hearing whispers not in the air. In the data streams, here's the terrifying truth: we're not just failing to recreate the crystals, we're proving they shouldn't exist. Every lab disaster reinforces the same lesson: the cluster isn't playing by our universe's rules. Maybe it's from somewhere else, maybe it's rewriting the rules as it goes. Either way, until we understand what's really humming in the heart of NGC 262, our best experiments will keep ending the same way, in smoke, silence, and questions that outnumber the answers. Because sometimes the universe isn't just hiding its secrets, it's guarding them. Buried within NGC 262's cosmic oddities lies a question that haunts every astronomer who studies them. What if these aren't just freakish natural phenomena, but artifacts, relics of civilizations so advanced their technology has blurred into the fabric of the universe itself? Galactic archaeology, the study of such potential remnants, suggests that sufficiently advanced engineering might leave signatures indistinguishable from natural law. Take the Black Hexagon. Six-sided voids don't emerge spontaneously in nature, but they do in blueprints. Megastructures like Dyson swarms or quantum computational arrays could theoretically self-correct their geometry over eons, their repair mechanisms outliving their creators by millennia. The Fibonacci supernova remnant offers another clue. Natural explosions don't sculpt themselves into golden ratio spirals any more than a grenade blast arranges shrapnel into a Fibonacci sequence. Yet certain theoretical propulsion systems like Alcubierre drives warping spacetime leave behind mathematically precise turbulence patterns when catastrophically disabled. Imagine a starship's engine core detonating mid-jump, its malfunction imprinting the ship's navigational algorithms onto the resulting nebula like a fingerprint in ash. The remnant's 17-year pulse cycle even mirrors hypothetical reset protocols in advanced AI architectures, where systems perform self-diagnostic checks at prime-numbered intervals to avoid synchronization crashes. Then there's the eeriest parallel of all, the plasma sculpture's mimicry. Its ability to replicate humanoid silhouettes and ancient Earth structures suggests a technology that doesn't just record history, but interacts with it. Some models propose mnemonic plasma, a hypothetical medium where ionized gas could store and retrieve information via controlled magnetic knots, effectively turning nebulas into cosmic hard drives. If a civilization encoded their cultural memories into such a system, accidental reactivation might explain why the sculpture cycles through recognizable forms like a museum display glitching through exhibits. But the most compelling evidence might be what's missing. The Dyson sphere candidate's unnatural dimming patterns imply incomplete construction, suggesting their builders vanished mid-project. Were they wiped out, or did they transcend into something beyond megastructures? The quantum crystal cluster's time-entangled particles hint at an even darker possibility. These artifacts might not just be remnants, but messages, deliberately engineered to remain legible across eons by embedding their data in physics itself. After all, the one language that never goes extinct is the periodic table. If true, we're not just studying a galaxy, We're walking through a museum where the exhibits are still active, still whispering. And the greatest lesson might be this: intelligence isn't just something the universe has, it's something it becomes. Given enough time, even gods leave fossils. And in NGC 262, we might be staring at theirs. NGC 262 isn't just a galaxy full of oddities. It's a full-blown rebellion against the laws of physics as we know them. Take a step back and the pattern becomes impossible to ignore. From the Black Hexagon's geometric defiance to the quantum crystal cluster's time-bending entanglement, these aren't just quirks of nature. They're contradictions, the kind that make textbooks shudder and force scientists to scribble frantic equations in the margins. If the universe were a courtroom, NGC 262 would be the defendant calmly presenting evidence that gravity, relativity, even causality itself might be negotiable. Start with the basics. General relativity has been the backbone of cosmology for over a century, explaining how massive objects warp spacetime like a bowling ball on a trampoline. But the gravity well paradox flips that metaphor on its head here. Objects don't roll toward the dent, they roll uphill as if the trampoline's fabric somehow repels them. Even stranger, the paradox's effects are localized, like a glitch in reality's code that only activates within a 7-light-year radius. No known form of matter or energy behaves this way. Dark matter, it bends light predictably, negative mass purely theoretical, yet in NGC 262, the impossible is just another Tuesday. Then there's entropy, the universe's relentless slide toward disorder. Everywhere we look, from dying stars to crumbling mountains, nature abhors a vacuum, but loves a mess, except in this galaxy. The Fibonacci supernova remnants' pristine spirals laugh at entropy, maintaining perfect golden ratio curves centuries after the explosion that birthed them. It's as if someone hit pause on chaos itself, freezing the debris in a moment of mathematical grace. Even the impossible rings, those celestial hula hoops spinning at mismatched speeds without collision, mock the inevitability of decay. Normally, gravitational interactions would have turned them into cosmic dust bunnies eons ago. Instead, they pirouette undisturbed, their particles avoiding each other like strangers in an elevator. But the real crisis, causality. The trinity of light's synchronized pulsars ignore the speed of light's cosmic speed limit, communicating instantly across distances that should take millennia to bridge. Quantum entanglement can explain microscopic spookiness, but scaling it up to stellar proportions, that's like trying to build a skyscraper out of quicksand. And the time dilation cloud doesn't just bend time, it shreds it, creating pockets where clocks tick at random like broken metronomes. If time isn't a steady river here but a choppy sea with rogue waves, how do you even define now? The unsettling truth is that NGC 262 might not just break our models, it might render them obsolete. Some theorists whisper of post-physics, a framework where the rules change based on some deeper, hidden variable we haven't discovered yet. Others suggest the galaxy could be a cosmic sandbox, a region where fundamental constants were tweaked during the universe's infancy, creating a pocket of altered reality. Imagine a patch of forest where trees grow in perfect cubes instead of cylinders. That's NGC 262 on a galactic scale. Yet the most provocative idea isn't that the laws here are broken, but that they're different. We assume physics is universal, but what if it's more like a dialect varying slightly from galaxy to galaxy? The cosmic computer's pulsing binary code could be the key, a Rosetta Stone translating between our universe's rules and NGC 262's. After all, if the universe can encode mathematical truths in sunflowers and seashells, why not in starlight? One thing's certain, this galaxy isn't just a curiosity. It's a challenge, a cosmic gauntlet thrown at the feet of science, daring us to think bigger, dig deeper, and admit that some pages of the universe's rulebook might still be blank. For decades, SETI radio telescopes have swept the skies in quiet desperation, hunting for the faintest whisper of intelligence beyond our world. But few targets have drawn as much covert scrutiny as NGC 262. Leaked internal documents reveal that since 1983, this peculiar galaxy has been the focus of a classified subprogram Project Loom, tasked with decoding signals from its most anomalous objects. What they found wasn't just static. Early intercepts from the Arecibo dish set the tone. In 1987, astronomers recorded pulsed emissions from the region near Object 27, the Trinity of Light's leading sphere. At first dismissed as pulsar interference, the signals resolved into a repeating 12-second loop, 9 bursts of precisely modulated radio waves, each separated by intervals matching prime numbers. The pattern bore an uncanny resemblance to the Arecibo message, humanity's 1974 broadcast to the stars. But here's the chilling part: our message took 25,000 years to reach NGC 262. These echoes arrived just 13 years later, as if something had intercepted and replied near instantly. Declassified memos from 2002 revealed deeper unease. When SETI trained the Allen telescope array on the Singing Comet, its harmonic sequences began incorporating exact replicas of test tones beamed from Earth, a feedback loop occurring faster than light could traverse the distance. Researchers dubbed it the mirror effect, noting similar anomalies around the plasma sculpture. During a 1998 observation, its shifting forms briefly reconstructed the Arecibo telescope's silhouette down to the support cables, as if studying its observers right back. The most explosive leak came in 2018, a suppressed paper from SETI senior astrophysicist Dr. Elena Voss. Her team had isolated a repeating 81-minute signal from the Black Hexagon's coordinates, not electromagnetic but gravitational. Ripples in spacetime itself, vibrating at frequencies that, when visualized, formed a three-dimensional cube, not a natural waveform, a carrier signal. Buried in its harmonics were mathematical constants accurate to 15 decimal places, alongside isotopic ratios of transuranic elements no star could forge. The conclusion was inescapable: something was transmitting, something that understood atomic physics better than we did. Yet for all these discoveries, Project Loom's files end abruptly in 2021. The official reason cites reprioritization, but internal emails tell a darker story. After the cosmic computer's pulses began matching classified nuclear launch codes from the Cold War-era codes never transmitted to space, the program went silent. Whether this was a security measure or something else remains unclear. What is certain, NGC 262 isn't just whispering, it's speaking in a language we're only beginning to recognize. And the more we listen, the more it sounds like the universe isn't just alive, it's watching. Imagine launching a probe toward NGC 262, a journey spanning millions of light years through uncharted cosmic terrain where the very laws of physics seem to rewrite themselves. This isn't just science fiction, it's the audacious goal of Project Starloom, a coalition of astrophysicists and engineers drafting blueprints for humanity's first interstellar mission to this enigmatic galaxy. But reaching these anomalies isn't just about distance, it's about redefining what's possible. Current propulsion tech would take millennia to cross the void, so researchers are racing to crack the code of breakthrough technologies like antimatter drives and laser-powered light sail systems that could slash travel time to mere centuries. Even then, the challenges are staggering. How do you shield a spacecraft from the time dilation cloud's chaotic tides, or navigate near the gravity well paradox, where navigation algorithms might suddenly fling your probe off course? Yet the obstacles aren't just technical, they're ethical. The moment we detect signs of intelligence, like the Trinity of Light's synchronized pulses or the Singing Comet's harmonic code, we're forced to confront a chilling question: should we reply? The debate splits the scientific community. Optimists argue that engagement could unlock millennia of knowledge. pointing to the cosmic computer's binary signals as a potential trove of galactic history. Skeptics, though, invoke the dark forest hypothesis, the idea that advanced civilizations might see contact as a threat inviting catastrophe. After all, the plasma sculpture's eerie mimicry suggests something in NGC 262 doesn't just observe, it responds. Then there's the question of contamination. Sending probes risks introducing Earth microbes to alien ecosystems, however improbable life there might seem. Reverse contamination is equally terrifying. What if the quantum crystal cluster's time-bending properties hitch a ride back to our solar system? Protocols are being drafted, drawing lessons from Mars rover sterilization and the Voyager Golden Records, but NGC 262's anomalies defy all precedents. Some propose sending dumb probes AI-free, devoid of complex systems that could be hijacked or misinterpreted. Others advocate for purely passive observation, like the proposed Hyperion Array, a fleet of space telescopes so sensitive they could map the Black Hexagon surface from Earth's backyard. But perhaps the boldest idea isn't to go at all. The celestial filament's light-bending properties suggest it might function as a natural wormhole stabilizer, a theory fueling research into bridge probes missions that wouldn't traverse the distance but fold it, leveraging the filament's exotic matter to create a shortcut. If successful, we'd bypass centuries of travel, arriving at NGC 262's doorstep within a human lifetime. The catch: no one knows what happens to spacetime in the process. Early simulations predict catastrophic gravitational shear, but a rogue faction of physicists insists the risk is worth it. Their mantra: you don't study a storm by waiting for it to pass. Amid these debates, one truth emerges: exploring NGC 262 isn't just about unlocking its secrets. It's a test of humanity's readiness to confront the cosmic unknown. Because out there, beyond the edge of our understanding, the galaxy isn't just waiting, it's watching, and how we choose to reach for it, or whether we dare at all, might be the most defining decision we ever make. The next chapter of this story won't be written in equations or mission logs. It'll be written in the choices we make today, as we stand at the precipice of something far bigger than ourselves. And in the silence between the stars, those choices echo louder than we know. From the ghostly defiance of the Black Hexagon to the haunting melody of the Singing Comet, NGC 262 isn't just a gallery of cosmic oddities, it's a full-scale rebellion against everything we thought we knew. 30 objects, each more baffling than the last, stand as monuments to the universe's untamed creativity. The Twisting Nebula's backward spin, the gravity well paradox's defiance of mass, the quantum crystal cluster's time-skipping particles, these aren't just quirks. They're evidence that somewhere in the cosmic rulebook there's a chapter we haven't been allowed to read. Consider what binds them together: precision where there should be chaos, intention where we expect accident. The Fibonacci supernova remnant spirals don't just look designed, they are, down to the last decimal of the golden ratio. The Dyson sphere candidates pulse with the rhythm of a heartbeat, their shadows too geometric to dismiss. Even the plasma sculpture's eerie mimicry feels less like random turbulence and more like a language we haven't yet decoded. This galaxy doesn't just break rules, it rewrites them in real time, leaving us scrambling to keep up. And yet, for all we've uncovered, the most unsettling question lingers. What if we've only scratched the surface? NGC 262 stretches across millions of light years, and we've glimpsed barely a fraction of its depths. Could there be structures so vast their scale dwarfs our comprehension? Phenomena that make the time dilation cloud look like child's play? The cosmic computer's transmissions hint at calculations beyond our grasp. What equations might it be solving in the dark? Perhaps the greatest mystery isn't in the objects themselves, but in what they imply. A universe where physics is fluid, where time is optional, and where the line between natural and artificial blurs into nothingness. So here's the challenge we leave you with. If these are the anomalies we've found, what impossibilities remain hidden in the void? Share your wildest theories below, because in NGC 262, the only limit is the universe's imagination, and it's already playing by rules we've yet to discover.